Hello, welcome to this session on understanding the map projections. In this session, we will be talking about what is map projection and why do we require it. So let's understand this in a very fundamental terms. Supposedly, I have a globe and consider the globe to be transparent. Now, if I have a light in the center of that globe and I draw the lines of latitude and longitude around that globe, what would happen? If I have a sheet of paper and I project the light from the center of it, all the all the latitudes and longitudes that I have drawn on the globe would be projected onto the paper. So that is what is basically projection when you try to represent a three-dimensional surface or the earth surface onto a flat sheet of paper. So there are two things into this. First, you are converting a three-dimensional picture into a two-dimensional picture. Then secondly, while converting a three-dimensional picture into a two-dimensional picture, there is certain kind of distortions which occur. It is similar to you have an orange and you try to peel it out. So if you are peeling it vertically, you will have a different shape, and if you are trying to peel it into a circular fashion, that would be a different shape. In either case, there would be distortion of the shape. Now, the distortions can be in various forms. One is the distortion of the shape, if the shape changes. The second is if the area changes. And third, if the scale or the direction change. So, let's start with understanding the concept of projection and why do we need to study it. So here, before we start any concept on projection, what is important here to understand is the projection coordinate system. So this is the coordinate system that we have for projection. It's similar to a coordinate system in any other field. So you have the x-axis, that's the horizontal axis. You have the y-axis, that's the vertical axis. Now, in the first block, that is this block, what happens is x and y both are positive. In this block, what happens is x remains positive, but y becomes negative. So here is the second block. Then third is this block where both are negative, and finally this block where I can say y is positive but x becomes negative. So these are the various phenomena that we need to understand for analysis of coordinate system. Now, as I explained, considering Earth as a transparent system, so consider this Earth as a transparent ball, and within the center of that Earth, if I cut it into two equal halves, within the center there is a light source. Now I have drawn all the latitudes and longitudes on the surface of the sphere or the ball that I have. When I am projecting light from this center and I have a sheet of paper behind, what happens is something which appears to be this. So this is what is basically the meaning and the technical concept of what is projection. Now when we talk about projection, this is a curved surface of an earth. And if I want to understand this section, what will I do is I'll show it on a plain sheet of paper, and this is the projection plane along which, for example, this is the section I'm trying to show on the sheet of paper. So this curvature which is there would become flat, and when this curvature is becoming flat, there can be distortion in various forms. Now let's understand what kind of distortions can be there. So as I said, the distortions are of three types. Let's understand one by one. The first is the conformal distortion. So you have the conformal distortion, conformal maps. What happens in conformal maps, as I said, there are three aspects. You have shape, angle, area, and scale. So these are the basic parameters that you try to preserve while changing any three-dimensional picture into a two-dimensional picture. So all these projections which would finally come out are used in forming atlas. In atlas, every map you will find at the lower side corner of the map, you will find the name of the projections on which this map is designed to. Okay, so let's understand first the conformal map. What happens in conformal map, you are trying to preserve the shape or the angle. So what happens here is all the meridians cross at 90 degree. Good examples of conformal projections are Mercator and Miller cylindrical projections. In both of these projections, you are trying to preserve the shape and the angle. It is good for a smaller region, like for the Mediterranean region, it's working fine. But as you can see towards the pole, there is lot of width and there is less of horizontal lines. So it basically preserves area only for smaller regions. That's one of the basic limitation of conformal maps. Other examples of conformal maps are Goode's Homolosine, and then you have sinusoidal, which is again considered as a conformal projection. Now, equal area projections. In this, you are trying to preserve the area. So, meridians and the parallels do not intersect at right angle, but you are trying to preserve the area. And when you are trying to preserve the area, you are basically preserving it for, I should say, the various projections like Gauss stereotype and equal area cylindrical. Finally, you have the equidistant, in which you are trying to preserve the distance. So some of the good examples of preserving distance is equidistant conical and equidistant cylindrical projections. These are mainly used basically for designing a smaller area. So you are trying to preserve the distances in these cases. Now, before we understand any of the projections in further detail, there are some terminologies we must be familiar with. So first is understanding the difference between elevation or altitude, and the next is azimuth. So what is the difference between azimuth and altitude? So azimuth is any line which is relative to the geographical north point on the horizon that is directly beneath the point which is being observed. So you have 2 points. The point which is straight overhead you is known as zenith, and opposite to that point is the nadir point. So zenith is exactly overhead you and nadir is exactly opposite to it. Then you can see the compass bearings are clockwise in the direction from the north. So azimuth angle starts from north. So anything relative to north, you have 90 degrees here. Here the azimuth would be 180 degrees and here it would be 270 degrees. Here it is 0 degree. So this is what is azimuth. On the other hand, we can say altitude is just the distance which is directly over at the person. So elevation is elevation or altitude is the observed of an observed object is based on finding the compass bearings on the horizon which is relative to the true north. So for example, if I draw a picture here, here is the center of the earth, here is the observer, and here is the star. So the distance between star and the observer would be the altitude. Okay, then there would be a center point which would be running from here to the observer, and that would be the azimuth. So in this simple terms, we can understand the concept of azimuth and altitude. Now, what is rhumb line? So rhumb lines are the lines that cut all the meridian at the same angle and show true direction. So here are where we can find the rhumb lines. So they are all cutting at the same angle. Now let's understand a different concept which is known as the types of projections we can say. So I can have the conical projections, cylindrical projections, and the planar projections. Now, when we talk about conical projections, it can be It can be of two types. First is the tangent, and the second is the secant. Now, tangent is you have the circle, and it just touches the sides. So it's exactly touching the side. It's like you are forming a cone which is exactly touching the side of the circle. So when you will open it out on the piece of paper, the kind of projection you will be getting is similar to this. Okay. The best example of conical projection is polyconic projection. Now this is what is tangent. What is secant is, it is cutting through a section within the earth. So it's not just touching the outer surface of the earth, but it's going through the section on the earth. So that's what is the secant projection. When you open out the secant projection, this is what comes out to be. So these are the type of conical projections when you have a sheet of paper and you are putting it into a conical format. Okay. The next is the cylindrical projection. In this, what you try to do is you have a sphere or a globe with you and you cover the paper all around it. So all around it, if you are covering the paper, this is the normal cylindrical. If you cover it on the other side, it becomes the transverse cylindrical. And if you are covering it at an angle, it becomes the oblique cylindrical. The best example of cylindrical, which is changing to equator, that is the first case of the normal cylindrical, is a Mercator projection. So Mercator projection is exactly what it is, perpendicular to the equator. The second is the transverse projection, which is perpendicular to any of the meridian. The example here is transverse Mercator. And finally, if it is tangent to any of the great circles, like this is one of the great circles it is getting tangent to, so that is known as oblique Mercator. So these are the three kinds of cylindrical projections that we come across. And finally, the most important one is the planar or the azimuthal. We already understood what is azimuth. So we have the azimuthal projection here. If it is tangent to the pole, it is known as polar projection. If it is tangent to equator, it is equatorial projection. And then a planar projection can be oblique if it is oblique to either of it. So if it is touching single point, it would be tangent. If it is cutting through a section and covering a small kind of circle, it would become a secant projection. Similar to this, if it is cutting here, if I take a cross section of this would appear to be a small circle here. So this becomes the secant projection. Now we already studied what is cylindrical projection. There is a similar projection to cylindrical which is known as pseudo-cylindrical. Pseudo, as the word we know, pseudo means false. So pseudo-cylindrical projections are the projections where you have straight lines and the parallels. Then they have equally spaced meridian, but all the other meridians besides the main meridian would be curved. The example of pseudo-cylindrical projection is Mollevite projection and Arcade projection. These are the two projections which are pseudo-cylindrical in nature. Now, the most important section that we need to know while understanding any projection is the polar aspect. So polar aspect is all about projections from where we started. So there can be three kinds of polar projections. Let's understand from the first diagram here. So here is the light source. So if the light source is at the center, it is known as Gnomonic projection. If the light source is at the corner of one side of the earth, it is known as Stereographic. Now what does it mean? Consider this ball to be transparent, and if I cut it from the center and I have a light in between, I keep the blue one is the paper here, I keep a paper here, this is what it projects out. So here is a Gnomonic projection and it would give you the picture of half of the earth, which is this. Stereographic, I put light on one end, I have a transparent ball and I see this transparent ball has all the latitudes and longitudes drawn on it, and I see what comes out onto the paper. So this is what comes out to be on the paper, and this is the stereographic projection. Finally is the orthographic projection. In orthographic projection, the source of light is at infinity. So you have the source of light very far, you don't know from what place the light is coming out, and all the lights run parallel. So as you can see towards the end, these are very close. So when you have the orthographic projection on paper, what comes out is towards the end you have very close lines that are drawn, as you can see here, these are two lines between which I am moving my pencil. And these two lines are so close as compared to Gnomonic, where the center lines are close by. Okay, so this is the major difference. So Gnomonic has the light source in center, stereographic at one end, and in orthographic, the light source is from infinity. So these are the very fundamental concepts on projections. We would be talking projections in detail. You have a list of various kinds of projections, which preserves the area, which preserves the shape, and which is which kind of projection. So that is something you need to learn. But this, what we have discussed today in today's class, is the basic essential element of understanding the concept of projections and the various types of projections. Hope you enjoyed this session. Have a good day ahead.